Welcome everyone to our regular CNCF webinar series that is a regular continuation of our meetup series after the KubeCon Cloud Native Con, one of the biggest events that has happened in the Kubernetes and the Cloud Native world, and this happened last week. And today we have our presenter Nick Chase from Mirantis, who is going to describe us how to enhance your control over Kubernetes with Spinnaker and Continuous Delivery. Go ahead with your part.
Good morning, everyone. Thank you, Ihor. Thank you to everybody who is here. I appreciate it. As Ihor said, I am Nick Chase. I am in charge of technical and marketing content for Mirantis. I also am the editor-in-chief of Open Cloud Digest. Today we are going to be talking about Spinnaker and continuous delivery and how that relates to Kubernetes. Before we go on, I just want to kind of give you a quick heads up. If you are interested, we have a beta of a product that is based on Spinnaker, but we're not going to really get into that here. I'm just going to kind of drop that as a link. All right, let's talk a little bit about what we're going to talk about. So we are going to cover sort of Spinnaker for Kubernetes speakers. There's a lot of similar terms that are used differently, so it can be very confusing. So I'm going to kind of do the translation there. I'll explain, what is Spinnaker and what does that actually mean in terms that we Kubernetes people can understand. I'm going to talk about how Spinnaker deployment on Kubernetes works. Deploying Spinnaker can be, shall we say, a little challenging under some circumstances. I'm going to talk about the tools that it integrates with. It is a very good tool for linking together a lot of the pieces of the software development ecosystem. Then I'm going to talk about pipelines. These are very flexible and powerful ways to make sure that your Kubernetes resources are deployed in the way in which you most need them to be. We're going to talk about automated and manual approvals, and then we're going to talk about different deployment strategies and multi-cloud deployments. We're also going to see a nice demo of how all of this works. I'm going to take you on some tours, and then I'm going to show you an actual demo of a real application, which is fun. All right. So moving right along, let us kind of start with the lay of the land. If you are already familiar with continuous delivery, I'm going to ask you just to indulge me for a minute, particularly because there are a lot of people who have heard of it and they think they know what it is, but if you really dive in, you find out that they are not necessarily familiar with how it's really done. So let's just take a minute and refresh. So you're a developer. We all know developers like to use what they like to use, and that's that. But the idea here, the CI part of CI/CD, is that you build your code and you don't just throw it over the wall. You build it and you have an automated pipeline that tests it. You've got your unit tests, you've got your infrastructure, your integration tests, you've got acceptance testing. All of that should be done in an automated way in order to make sure that every time you commit changes, you're not breaking things. That's the whole idea behind continuous delivery, is that one fix doesn't take the whole thing down. Just because somebody's working on something doesn't mean that the whole thing is unavailable until they are finished with that. Now, that build and test process creates an artifact. It's some binaries, it's whatever it is, and those are passed into the actual continuous delivery part of the equation. And that's where it gets handed off to operators. These are the people who make sure that the code can go where it needs to go. And normally that is taken care of with scripting. It could be Helm, it could be Puppet, it could be Ansible, it could be something custom, it could be whatever it needs to be. But that one part of the puzzle where a lot of places fall down is those deployment scripts should be as tested as the rest of your code. And that's not necessarily the case. So you want that to be as automated as possible, okay? Now, once you've got that script typically deploys with a particular release strategy. And those strategies are, there's any number of different types. There's, you've got them, you see them listed here. Blue-green, also known as red-black. We're going to talk a little bit about that later. Canary, which, where you roll out a little bit and make sure that it's working and then gradually roll it out more. Rolling updates, as Kubernetes developers, you're likely familiar with that, where you roll out a little bit and then you take down the old one, and so on. But you'll notice that these release strategies are independent of where it's actually going. That is the ideal situation, where as a developer, you just need to build your code. And then it's going to end up wherever it needs to end up. Maybe it's going to Kubernetes, maybe it's going to AWS, maybe it's going to OpenStack. You shouldn't have to care. Okay, so that is sort of our quick refresher. Now, so what does this have to do with Kubernetes? Well, if Kubernetes was simple and if Kubernetes applications were simple, this would be easy. You wouldn't need to worry about all this. But as you probably know, that is not the case. Any Kubernetes application that is non-trivial is going to be fairly complex, particularly if you are using the microservices architecture. On top of that, Kubernetes applications have a lot of moving pieces in terms of the infrastructure. Ideally, and really honestly, if you're not doing this, you can't really call it continuous delivery. But ideally, your infrastructure itself is treated as code. So all of this has to be tested. It all should be scripted. Now, there's a lot of problems, though. A lot of this is handled in an ad hoc way in a lot of organizations. They do it. Now, the problems with that is you've got security issues, first of all. As Kubernetes developers, we work with a lot of containers. They've done studies and show that I forget what the actual percentage was, but a significant percentage of images on Docker Hub have pre-existing vulnerabilities on them. I want to say it was an average of like 16 vulnerabilities per image or something like that, but don't quote me on that because I'm not sure what the actual number was. But it was an eye-opening number. Now, the way to get away from that is to produce what are known as golden images. So your operations team might put together, okay, if you're going to use, this Python base image, great, but you need to use this one here because we've already made sure that it doesn't have any vulnerabilities on it. We've already, locked down this, that, the other thing, and so on. So you can produce those golden images, which is great, but you got to make sure that they get used, which gets us down into compliance. We're coming up on GDPR on May 25th, which, if you haven't heard of it by now, you're probably not in this webinar. Huge security and compliance burden, but that's not the first time it's come up. There was Sarbanes-Oxley If you're in the US, you undoubtedly have heard of HIPAA and all the security involved there. So when it comes to your applications, you really need to know what is running, where is it running, and who said it should run there. So you need to be able to track all of that. And all of that involves a great deal of coordination. You need to know the who, what, when, where, and how is this all going to work. And the problem with ad hoc is, well, it is ad hoc. So one of the things about Spinnaker is it takes all of this and puts it into a single auditable interface for continuous delivery. It's incredibly powerful. It takes things to sort of like the next step beyond the coordination you can do with Kubernetes. It takes it to the next step. You'll see that. It is an open source tool. It was pioneered by Netflix and Google. It's got huge uptake. The pace of development is really quite rapid, to the point where you go to the bi-weekly meeting and they say, oh yeah, we've got a new version, and it's nobody blinks an eye. So yes. All right. Anyway, let's do a quick tour here. I have a problem because this interface is in my way. Okay, here we go. So let's just kind of do a quick tour. This is not a vanilla install of Spinnaker for various reasons, technical, that have to do with my laptop and how the technology gods hate me. But this is basically just a look at Mirantis application platform, which is a Mirantis branded version of Spinnaker with some things on top. So, but all of this is going to apply to generic Spinnaker. Okay, so you can search for things, you can group things by projects, but mostly we're going to look at applications. Within applications, you have clusters and pipelines and tasks. I'm going to go through all of this in more detail when we get into kind of translating what all of this means. But just to kind of look at the heart of what we've been talking about, I just want to give you a quick look at this pipeline. For example, we have a pipeline that starts by building a base Python image, deploys it to staging, and then runs tests on that staging environment, including security scanning. If both of those pass, then that stage gets shut down and it gets published to the repository. Okay, so this is kind of an example of what's going on. You have load balancers, which are the equivalent of services. We'll get into that in a minute, but just kind of to give you an idea of where we are. So all of this comes together. Now, let me go back to my slides. Okay. So how Spinnaker helps with all of this is, again, it provides you a single source of truth for all of these deployments. If you want to know how something works and how it's deployed, that's where you can go. If everything is always deployed through Spinnaker, then there is no question of Spinnaker being up to date, because if it's not, then it's simply not going to work. It gives you auditability because you can see who did what, and you can create these sort of templated pipelines that use these verified images and code, these golden images that we talked about before. All right, so let's kind of jump into Spinnaker for Kubernetes speakers, okay? So we've got, if we start at the bottom, pods are known as instances. You don't do much with those directly through the interface, but you can see them in server groups. We'll talk about that in a minute. Server groups would be the equivalent of a replica set, okay? So that would be the actual code and all of the configurations. How many do you need? Where does it go? And so on and so forth. Okay. A cluster would be a sort of wrapper for the server group. So it kind of corresponds to a deployment. And then wrapping all of those things up, in Kubernetes, we would call that a cluster. All of that put together is a cluster. In Spinnaker, it's an application. Okay, so moving sort of to the outside, a Kubernetes service would be a load balancer. So that would be how we can direct traffic to particular instances within Spinnaker, which in our case would be pods. Security groups, you have probably heard of those in terms of how cloud providers refer to them. For Kubernetes, we would refer to them obviously as network policies. All right, so sort of putting that all together, let me move this interface out of the way. So instances are grouped together into a server group. Server groups are grouped together into clusters, and clusters can be grouped together into applications. All right, now that's all great, but how do we actually do the delivery? How do we actually do the deployment? So what we do is we create pipelines, and we looked at those pipelines a minute ago. Each of these pipelines is made up of stages. Okay, so each of these is individual stages, and if we were to say, let me go to a different application here because I don't want to mess that one up. So let's just kind of take a quick look here. So if I were going to create a load balancer, let's say I wanted to put an application on Kubernetes. So I've got my kublocal account, which is my Kubernetes cluster, as in Kubernetes cluster, not Spinnaker cluster. See, I hate that they do that, but you get the idea. So these would be my Kubernetes namespaces, and I can pick which one I wanted to go in. And then the stack, so I might have a staging stack and a production stack. Okay, so like maybe I wanted, so now I've got a load balancer named webinar staging demo. Okay, so I might have webinar production demo. I can set the ports. You can see node port. I can add a new port and so on. You're recognizing a lot of these, I'm sure. So cluster IP, node balancer, node port. These are all familiar to you as Kubernetes developers. We can add external IPs, service annotations, and so on. So I can go ahead and create this. And there's a task view that shows all the tasks and their various progress. I've got a couple here that I stopped for various reasons, but you can see everything that was done, and you can see who did it. So that is a very important piece of the puzzle. We have, so if I go over here to clusters and I want to create a server group, so now I'm ready to go ahead and create some infrastructure on which to put this application. So I can decide, where I want it. I'm just going to leave everything in the main namespace for now. So I'm going to put this in staging as well. Oops, helps if I type correctly. Have I mentioned that the technology gods hate me today? And then I can define which containers that I want. Now, what shows up here under containers is going to be based on the repositories that are configured into Spinnaker when you create it. okay, when you install it rather. So for example, if I wanted to say create a Jenkins server group. Okay, so I'm saying, okay, yeah, I want to make it a deployment. Here's a rolling update. I want my max surge to be, 3 and max unavailable 1. Now, but where's it going to get served? Okay, well, here's our webinar staging demo load balancer that we created a minute ago. We can set up auto scaling. You can see here, we can base it on a CPU target, and so on and so forth. So you can see that all of these options are available to you. In the container itself, we've got the image, we've got the name for the container. We can change that if we want. Basic settings, arguments, environment variables, all of these things are familiar to you from your deployment YAML. You can set resource limits and requests. Again, these are all things that should be familiar to you as a Kubernetes concept. But you can go ahead and encode them into Spinnaker so that you know what they should be, and they are not sort of ad hoc, as I said. Okay, how is this going to run, and so on. I didn't really pay much attention to what I was putting in here, so I have no idea whether this is going to come up properly or not. But you can kind of see what happens here, and we can go ahead and just kind of monitor this from the task bar if we wanted to. All right, so that kind of gives you a little bit of a feeling for that. And pipelines, we can go ahead and we can create new pipelines. I'm going to call this deploy to staging. And again, you can see there, whoa, hello. I have no idea why that happened. Well, that's how you know it's live. But don't worry about that right now. Let me come over here. Okay, so you can see the different kinds of staging. So you can create a pipeline that triggers on various things. Cron jobs, changes to Git, Jenkins jobs, Travis jobs, the completion of another pipeline, perhaps pub sub from Google, webhooks, changes to the Docker registry. All of these can trigger a pipeline. Okay. Let's see here. So let me just kind of look at, if you want to add a stage, I want to show you here. So what you can do is you can have stages that do various things. You can check for preconditions. Did a particular script come through in a particular way? Did a particular pipeline execute? And so on and so forth. You can deploy in two different ways. This shows how to deploy previously baked images. A later version of Spinnaker also includes the ability to deploy via manifest files. You can destroy server groups, disable clusters. You can see here, you've got pretty much all of this control from the interface. Okay, so I am apparently running behind, so I'm going to jump right through here. Deployment strategies, we'll see that as we go along. All right, now, so there's various steps here for deploying on Kubernetes. You've got Halyard is the configuration tool. You use it to configure the environment and Spinnaker, and then to go ahead and deploy it. You've got three different choices. Local Debian and local Git this basically means check it. Local Git means basically check it out and run it. Local Debian means deploy it on your local machine. If you're going to do Kubernetes, distributed is what you want. Okay, there are various providers that you can use here, as you can see. I'm not going to go through all of them, obviously, because the only ones we're interested really are Kubernetes. But just know that they exist. Again, Kubernetes Legacy is what we were looking at, Kubernetes v2, manifest-based. You can store you have to have a persistent storage. There are lots of options. If you haven't heard of Minio, Minio is basically a local version of S3. So basically, when you go ahead to deploy, let me just kind of grab this here. You can see what you've got configured with Halyard. And I'm just going to kind of show this here. So you can see you've got all of your various pieces. Like I have, in this case, a Kubernetes account that's just using my current kubeconfig, and so on. And then you can just do hal deploy apply. Okay. So, and then that'll go through and run. And how it actually runs is going to be based on what your provider is and so on and so forth. So I'm not going to sit there and watch that because, again, we're running a little bit behind. But, okay, so let me just kind of jump back here. Okay. There are various versions. The simplest way to deploy is to use, this, the quick deployment. This is going to be obviously the most Kubernetes friendly, as you can see here, kubectl. I'm going to actually get out of this right now, just because I want to show you the kubectl really quick. This is the simplest way to do it. You do not have to go through a million steps, and believe me, there can be a million steps. You notice here, it just went ahead and it did everything. Okay, so, and then I can check it. I can get pods for the Spinnaker namespace, and I can see what's running. You can see that it's gradually going to go forward and do that. All right, now, let's get back to the right window. There we are. Okay. So just quickly to show what other tools can be integrated with it. You've got Jenkins and Travis for CI/CD, various artifacts. So you don't have to define specifically the binaries or the code that's going to go in, but you can define where to get it from. Okay, so Google Cloud Storage, obviously GitHub, or just directly from HTTP. For monitoring and metrics, which becomes obviously very important even if you're not using Canary deployments, but obviously also for Canary deployments, Prometheus, obviously, Stackdriver, Datadog are all available. You would configure them with Halyard. And notifications, what we're going to see is you can actually set manual steps so that something is not going to go live until somebody manually approves it. And you can configure Spinnaker to send notifications for that to Slack and email and HipChat or via a text message. Security, you can, obviously you want to control who gets in. You can use Google Groups, GitHub Teams, LDAP, and SAML for that. And you need to be able to, terrible when the brain falls out, isn't it? You need to be able to create these images using a bakery, and Spinnaker gives you the ability to do that with Packer. And you can configure the provider bakery. So you know, whether you're baking it with Kubernetes or with OpenStack or Azure or whomever, you can go ahead and configure how that's done and where it's done and where to find the artifacts. Okay. Now you can use various triggers. and so on. Canary, I touched on Canary briefly. Canary deployments are when you roll out to a small bit to make sure that it's all working. And if it is, you roll out to more. So you can configure all of that. There are various providers involved there. All right. Let's kind of quickly run through a demo of how this all works. Let me back out of here. Okay, I still have a couple of minutes, not many. Where am I? Hold on. Here we go, here we go. We've got a video of the demo just so we can kind of make things go faster if necessary, which obviously is necessary at the moment. So here we go. So if you notice here, we have these pipelines, and the pipelines are set up to trigger when there's a change to the source. In our case, we use Garrett, but you could also use, I mean, you could use raw, Jenkins, Git, whatever. So in this case, we have an application that pulls data from Twitter and makes a cloud, a tag cloud. So what we've done just now is we've changed the version of Python to Python 3. And as you will see in a minute, that will automatically trigger the build pipeline that builds the base image. Okay, and come on, let's go forward to where we are. Come on, there we go. So you can see here the pipeline got triggered, and it is building the image, and so it's going to take a second to do that. And you can see here the different stages. This is the pipeline we looked at earlier, where it deploys to staging and then does a test on staging and runs a security scan and so on. Let's kind of skip ahead here a little bit. So yeah, so let's see. If we look at the security scan, you can actually get the console output, which shows that in this particular image we do have the vulnerability that comes with wget. So you can see that particular information right there in the console, and then you can make a decision. You know, do I want to move forward? This is using Claire, which is the CoreOS open source API to do that. So you can make that decision on whether you want to move forward or not. Now, if we go ahead and reload, we can see that production is not there, has not been changed rather. So let's go ahead and make another change. We're going to go ahead and change the code for the application itself in this case. And we're just going to make a change to the actual text that goes on the page. You can see here he's putting in the date. And I'm just going to kind of move forward. So he's going to go ahead and approve that change. And that's going to kick off a Jenkins job. Okay, so you can see that so we've got all these jobs in here. And that Jenkins job is going to kick off a different pipeline, which is in a different instance of Spinnaker in this case. So we're going to go, he's going to pull that up in a second. There we go. So there's the Twitter app. And there's that triggered build right there. Now this one's a little bit different because you can see it's going to deploy to staging. It's going to run the tests on staging. It's going to scan the image. And before it can go to production, it's going to have to be manually approved by someone. Now, this is kind of what's called a red-black deployment or a blue-green deployment, where we've got, well, I shouldn't say that this is, but this is similar to that in that we've got one set of instances that are running, and if we decide we like it, we're just going to switch all the traffic over to that set and get rid of the other one. So one way that some people implement that is they have two identical environments. They have their staging environment and they have their production environment. And if staging goes well, they just shunt all their live traffic over to staging, and that becomes the new production, and the old production environment becomes the new staging environment, and so on and so forth. So this here shows that we've got the request for whether this can go to production or not. It included a link to the live version. So they went and looked at this is staging. Yes, it's there for Python 3. So now, do we want to go ahead and promote that? Yes, we do. We're going to continue. So now it's going to go ahead and deploy it to production and shut down staging. So you can see that, you know, we already have the security. We already know about that, and so on. All right. So and it shut down the original staging. So there we go. All right. Okay. So that brings us to the end of the demo. I know that we kind of blitzkrieged through that, but we still have a few minutes left. So let me just kind of get back to my slides. All right. So you can see what we did here is we have the application services team, otherwise known as the operators. They created all these golden images. They put it in the registry, and they created these pipelines, which the dev team can then use to deploy to staging or production. So that's what we just saw. And that brings us to the end. Again, you can sign up for the beta. If you want to see that demo in a way that is not spoken so quickly, you can go ahead and sign up for the next one, which is on May 16th. And they'll be doing it live, so you can actually ask questions at that time. So speaking of questions, where are we, Igor? Do we have any particular questions from the audience?
Right. Thank you, Nick. It was an amazing presentation, and I hope it was really valuable for everyone who watched it. So we have a few questions right now. So let's start from, does Spinnaker have an API?
Does it have an API, you mean?
Yeah.
Yes. Yes, Spinnaker does have an API. It's really actually quite powerful. Let me just kind of jump over there for a minute. If you want to get all of the information, you can go to spinnaker.io. There is, you can go here to the reference section. The reference section typically is going to show you how all of this works, and it's going to give you a gazillion Halyard commands for backing up all this stuff. I didn't have a chance to really cover that too much, but I do want to just kind of give you one, and then I'm just going to jump over to the API. But if you look here, if you're adding, you can go ahead and add Kubernetes as a provider. I wanted to cover this, but we sort of ran out of time. But you can add it as a provider, and you can see what you're adding in here. You're adding, you know, where are the secrets, what's the context, and so on. A lot of this is optional. Basically, you're just trying to add the account so that Spinnaker knows where to look. But as for the API itself, it's up at the top, come on. Okay, yes, but as for the API itself, you can see all of the various calls here on the site, and you can see that everything that you can do can be done using the API. obviously uses the microservices architecture, which is great because that means that you can script this. You can script this as well as you can script anything else, which is of course very important. Okay. Let's see. So what other questions have we got?
Yeah. So speaking about hardware, is this the only way to install?
No, it is the most common, but it is absolutely not the only way. I believe we actually use Terraform, but I'm not sure. I'm pretty sure we use Terraform. I've been using Halyard, but there's, like I said, there's Terraform. There's a few other ways to do that as well. Yes, and I can get more information on that if anybody is interested. But I think you can use Docker, you can use Helm as well. There is a Helm install for Spinnaker. Halyard is useful after you've got it as well because you can always make changes to it.
Perfect. So another question is, can the Spinnaker driver for Kubernetes detect manifests that are not a part of a stack deployment anymore? If so, does it delete them automatically?
Can the Spinnaker driver for Kubernetes detect manifests that are not part of a stack deployment anymore? I am not. For a minute, I wasn't kind of clear on what the actual question was. I think what's being asked is if the object and if the object is deleted, if you do, kubectl delete -f, whatever, will Spinnaker pick that up? I don't know the answer to that. I think it is probably no. But I would have to check on that.
Perfect. Another question is, what is the difference between Kubernetes legacy and manifest-based providers?
Yeah. So the manifest-based provider is more of kind of what you would expect from a Kubernetes perspective. Whereas, you can write YAML files and, it just deploys things and it's very familiar to the Kubernetes way of doing things, which is, I think, why they did it, because the original legacy-based Kubernetes provider is more of a registry-based, here's this thing that's in a registry and we're going to deploy it as it is. And so it's more of a Docker it's more of a Docker style thing than a Kubernetes style thing. So if you want the sort of full Kubernetes experience, you want to go with the version 2 provider.
Got it. Another question is, how do you version Docker images?
So what you do to version things is you can define an artifact. You define an artifact. So like, let's say I wanted to use something that was in GitHub. So I would define the GitHub artifact. And then you can then do this a couple of ways. First off, you can trigger a pipeline when that changes. But the other thing that you can do is you can create a pipeline that specifically is going after a particular container image. You saw that when we were looking at creating a let me see if we can get back there so I can show you. When we looked at creating a pipeline, when we looked at configuring a pipeline, you saw that, well, actually, you didn't see this in the pipeline. You saw this in the clusters. So you can set a specific image, including the version of that image. So, yeah. Okay.
Yep.
What else can I tell you?
So can Spinnaker kick off Helm-based?
Can Spinnaker kick off Helm-based deployments?
Deployments, right.
I don't believe that there is a direct way to do it. However, Spinnaker can kick off arbitrary scripts. Spinnaker can kick off arbitrary scripts, and there's no reason that that script can't be a Helm chart. So you could just have a script that calls a particular chart. So that would be one way to do it. Let's see if there's any. Let's see what else we got here.
Another question can be a bit out of scope here because it's more OpenStack related, but still Spinnaker are related. So if you're familiar with that, Nick, so we're happy to hear your thoughts about this. So in the case of OpenStack integration, can Spinnaker use the Magnum service to orchestrate your source?
In the case of OpenStack integration, can Spinnaker use Magnum to
right?
That is a good question. And I am thinking that, okay, actually I can answer that question. So the OpenStack provider, this is from the best of my understanding of this, the OpenStack provider is used to orchestrate OpenStack resources such as VMs. So if you are trying to orchestrate Kubernetes on OpenStack, you're actually using the Kubernetes provider, and the cluster that the Kubernetes cluster that you're targeting just happens to be on OpenStack. So the OpenStack provider itself, I am not 100% familiar with with what it provides to you. I don't know that it provides Magnum rather directly. I can't answer that definitively, but I don't think so. So I could be wrong. If I'm wrong, please somebody pipe up and say so. There you go.
Yeah, perfect. So the next question is it possible to create various stack deployments with dependencies? For example, let's say I want to use the Prometheus operator and I want to deploy a Prometheus instance. The Prometheus operator must be deployed first.
Oh, yes, absolutely. Definitely, because in fact, that's one of the advantages of using these pipelines. Because what you can do in that case is, first of all, you can put a precondition on the pipeline that the pipeline itself is not going to run unless a specific criteria is met. And that criteria may be checking to see whether the Prometheus operator has been deployed. It can be, although, well, yeah, I mean, that's one way to do it. You could include the deployment as part, the operator deployment as part of the pipeline. The main thing is making sure that everybody knows that they need to go through this process, rather than everybody just sort of, being the Wild West out there. It's usually people that are the problem and not the technology in a lot of cases. But it's definitely possible to do that.
Perfect. Another question is about the cloud support. So what is the feature of the DigitalOcean support, and what are the requirements of what provisioning support is needed to add new cloud providers to the provider's Spinnaker support? For example, add node support. Would you need strong Terraform support, Kubernetes Cloud Controller Manager plugin, Ansible?
Well, if the question is about Kubernetes support on DigitalOcean, then it seems to me that that would just be the Kubernetes provider. If the question is non-Kubernetes DigitalOcean support, how do you add a new provider for Spinnaker? I believe that that is actually covered on the Spinnaker website itself, I think. Oh, hang on, let's see. I would definitely go to the Spinnaker website. Here we go. Developer how-tos. Stage extensions. Yeah, there's. I think the place to go to ask is going to be either Slack or Stack Overflow. There is an active Slack community for Spinnaker. Also, another good place that you can go is community.spinnaker.io. They have it's a pretty active community. So I would ask that question there and see what they have to say.
Sounds good. The next question is about Cloudify. It's probably also out of scope, but if Unique have information about it, it would be great. So any chance of Kubernetes working with Spinnaker via Cloudify?
Oh boy. Yeah, that is definitely outside of my my realm of experience, but I would say I don't see why. I mean, it's certainly possible. Whether it's possible at this moment or whether work would have to be done, that I can't answer. So,
Yeah.
okay.
Yeah. So coming back to Spinnaker and Kubernetes, probably any alternatives which can perfectly work with Kubernetes.
Are there any alternatives to Spinnaker which work perfectly?
Right.
I'm not sure exactly on the context of the question. Spinnaker actually works really well with Kubernetes. There are really no places that I can think of where Spinnaker kind of falls down on the job in terms of helping you work with Kubernetes. It's a little bit convoluted, and it takes a little getting used to, but then, cast your mind back, so did Kubernetes when we first got started. So I am not up on all of the tools that are out there, but I would say actually that Spinnaker probably fills the bill in that case.
Sounds good. So the next question is more about your company and your services. So do you offer the managed support for Spinnaker as Mirantis?
Yeah, actually, Mirantis is offering managed support for Spinnaker, and I think I mentioned Mirantis application platform a little while ago. I would definitely, if you are interested in that, I would definitely encourage you to go here to mirantis.com/beta and check that out. I would strongly encourage you. I mean, it's nobody's going to hold a gun to your head, but I would definitely that. I would definitely encourage you to go there, and I don't know why I have somebody else's name on there, but go ahead and go to that URL, sign up, and somebody can give you information, but you can definitely get yourself in there first. It's there's been a lot of we've had a lot of excellent feedback on that. So let me see.
Perfect.
All right.
We have some extra time for the final question, and this question is going to be more generic than the previous one. So, how can I learn more about continuous delivery and specifically about Spinnaker and Kubernetes, so continuous delivery for Kubernetes?
Yes. I will tell you, I think my favorite resource is going to be a book called, it is called Continuous Delivery. This is not the right account. It is a book called Continuous Delivery, and I will tell you who the authors are in a minute. I meant to have that in my head, and I forgot. But the authors are Jez Humble, and here we go. This is it right here. So this is my current favorite book right now. Oh, for God's sakes. Here. Jez Humble and David. There we go, David Farley. This book right here. It is a long book, but it is absolutely worth it. It is an older book, so you might look at it and go, oh, you know, this is, but the concepts are still 100% accurate, and I would definitely recommend it. And it is available on Kindle, so you don't have to carry around this 400-page tome, and it is 400 pages.
All right, great suggestion, Nick. So we are almost out of time. Thank you, Nick, and all your team for amazing webinars and demos. I hope it was really valuable for everybody who is interested in integration of Spinnaker with Kubernetes and about the CI/CD processes at all. Thank you for joining us today. I'd like to also remind you that this session was recorded and it will be available shortly on the cncf.io website in the recorded events section. And we're going to have our next webinar next week, exactly the same time. Thank you for joining us today, and goodbye.
And I want to thank everyone for joining us as well. And thank you to the CNCF for having us.
Thank you, Nick.
Thank you.